Hello everyone and welcome to week 5. We are starting our new topic today. We are talking about limits, which for those of you that are going on to take calculus next year, this is kind of like that first section that you're going to do in calculus. For those of you going off to college next year and taking more math classes, you may have to take calculus and this will help you. Those of you not taking calculus, oh well, that's part of our curriculum. It really isn't super difficult though. The idea of a limit is just that you're talking about what is a function doing as it gets close to a value. Not what it does at that value, but as it's approaching that value and getting closer. I am recording this during my office hours because none of you ever come. Except like 3 of you. I shouldn't say none. There's like 3 of you. But I helped 2 of those 3 people today. So, you know. I assume that no one else is coming. So if there is 2 parts of this video, that's why I had to stop and go help someone during office hours. But I'm not going to sit here and do nothing, so I'm going to record some videos. If you'd like to come see me next week, I'm always here 2 times a week, every single day. I said 2 times a week, 5 times a week, 2 times a day, so 10 times a week. All right, let's go ahead then and get us started. Let me click over here. All right, so we are on page 36. Use this one up here. I don't know what I was doing. I accidentally put page 35 on my thing, and I've already corrected it, but you can't see that because I already took the picture of it, and I wasn't going to retake the picture. So change that to 36. Like I said, talking about a limit. Here, let me just change mine to 36 now. There. I can change it digitally. All right, so like I said, a limit is just the concept of what a function is doing as we are approaching a certain value. So as we're getting closer to a number, what's happening? So as our graph is approaching infinity, what is happening with that graph? Or as the graph is approaching negative infinity, what is happening with that graph? And that conversation will be more of what we talk about next week, but that is kind of how we're going to start by talking about it. Just so you can talk about function notation first. If I have a function f of x, the limit would be represented usually by L. And what we use is some other notations too. We say as x is approaching c, where c is some sort of constant. This is what it would look like. If I wrote out the notation for a limit, it looks like that. And the way that we read that is I would say the limit as x is approaching c of the function f of x, which a lot of times there'll be an actual function there, is equal to the limit L. Again, this will be some sort of an equation. C will replace with a constant, and L will usually be an answer in some sort of number form. So the limit as x is approaching some number of a function is equal to L. So with that, let's look at our first example. I have my first example just tying back into something that we did before. Right, the end behavior of a limit. Now, if we were just talking about this in simple, easy form, I might say, okay, it's going to fall on the left and rise on the right. Correct? We did that for a little while too when we did our polynomials. But if you were writing it out in a very proper math way, back then what we did is we'd said, okay, well as x goes towards negative infinity, then the function as a whole trends towards. So as my graph goes to the left, what does the graph itself do? Well, the graph goes down, so we'd say the graph also goes towards negative infinity. The fact that those 2 are equal is just a coincidence. That doesn't necessarily always happen, right? If the graph had looked like this on the left-hand side, then we would say as x goes towards negative infinity, the function goes towards positive infinity. So if I did the right-hand side, I would say as x approaches positive infinity, the function, well, look what's happening as we go towards positive infinity. The graph goes up, so we'd say the graph approaches positive infinity. So let's talk about then, how would we write that in limit notation? So we'd have something on the left and something on the right. So if I want to turn the left into a limit notation, then what we would say is we'd say the limit as x approaches some value. So let's start with if it's going to the left. So the limit as x approaches negative infinity of the function f of x, we don't actually have a function, we'll just call this f of x for now, is equal to, well, what happens as the graph goes towards negative infinity? Well, then the entire thing trends towards negative infinity as well because it trends down. Similarly, the notation on the right would be the limit as x approaches positive infinity of some function is equal to, so again, we look as x is going towards positive infinity, the graph itself is going towards positive infinity, so we would also put a positive infinity there. Again, a coincidence. This doesn't always come out the same. But that's kind of just your basic notation there and how to do that. So I wrote that a little bit cleaner. as always right here. So that would be a cleaner notation of that. With that, sometimes we're not going, like, honestly, we're not going to use infinity right away. Infinity will be for a future lesson. What we're going to look at first is as that c is approaching a certain value. So sometimes c is going to approach a specific value in which a limit is created. So as x is approaching some value, and we look at either side, as it approaches that value c, what does the function look like? This is not exactly what happens at that spot, right? It's what happens around that spot. So a good estimate of like when we would use limits and why limits might be important to us is, for example, if I had the function 1 over x minus 3. Well, I know that if I plug in 3 here, I get 3 minus 3 in the denominator, which is 0, so I have 1 over 0, so it's undefined. So I can't plug 0 in, but I could look at the limit as x approaches 3. And I could say, well, what happens as we get closer to 3? We know at 3 it's undefined, but as I get closer and closer to 3, what's happening? So like what's happening at 2.999 and at 3.001, or 2.998 and 3.002? As we're getting closer and closer to 3, what is happening? That's our goal to find out. So I have our first example first, or a second example, and I'll tell you with this example, I didn't choose one that had an undefined point. I don't know why I didn't. I just kind of pulled one, and it ended up not being undefined. So really, when it says estimate the limit of x minus 8 over x squared plus 4 with a table or a graph, I could try plugging in 2 and seeing what happens. I know what happens at 2, because if I plug 2 in, 2 minus 8 is negative 6, right? And 2 squared is 4, 4 plus 4 is 8. Well, negative 6 over 8 would be negative 0.75. That's an ugly decimal. So I know the answer already. That would be the answer. It doesn't always work that way, though. You can't always plug it in. You can only plug it in if it's not making something undefined. If it is making something undefined, we'd have to use a graph or a table. And so I'm going to do that just so we can see how to do it. I'm going to use my little graph here that's still set up from when I did this. I already recorded this video and it didn't work because I don't know why. I actually do know why. My dog unplugged my microphone, so I recorded the whole video without a microphone. Let me just reset everything so that we can talk about it. I'll explain everything that I'm doing in just a minute. Okay, so what we do then, if I want to actually test this out and see how this works, the first thing, let's try starting with the table. So I'm going to go into this y equals. If you're using a Casio, I'm sorry, I told you at the beginning of the year, I don't use Casios. I don't know how to use Casios. Figure it out. Go on Google. Go on YouTube. Someone will teach you how to do it. But with this TI, what we're going to do is we're gonna plug some stuff in. Also, if you don't have a graphing calculator, that could make this a little bit complicated. Try looking at Desmos. Desmos has some options. I don't know quite how to get to a table on Desmos, but I know there's a way to do it. You could try finding. I was given this for free because I'm a teacher, so I'm allowed to use this for a few months for free. But I have one on my phone, which I'm not supposed to have. But I found a way to get it, and you could do that too, just by Googling it. I'm not encouraging you to do things that are bad, but you could. There you go. So I'm going to put this in. So the equation is the limit as x approaches 2 of x minus 8 over x squared plus 4. So I need to put in that equation x minus 8 over x squared plus 4. So let's put that in. I'm going to go math over to my fraction. So in my numerator, I had x minus 8. And in my denominator, I had x squared plus 4. X squared plus 4. Great, so I have that in. Well, the first thing I want to look at is a table. And the problem is if I jump into a table right now, it starts here at 1. Oh, my settings didn't quite change the way I needed them. But normally I'd have like 1, 2, 3, 4 here. I don't want that, though. What I want you to actually do before you jump into the table is go to Table Set right above Windows. So you're going to press Second Table Set. This will probably say 1 and 1 here. If it doesn't, this is what we need to change. We want to change our table starting point to the point of which we're having x approach. In this case, x is supposed to be approaching 2. It says the limit as x approaches 2. So I want to change the table start to whatever x is approaching. So I'm going to change it to 2. My delta table, like I said, yours probably says 1. I don't want to look at the graph as 1, right? I don't really care what's happening at 0 and 1 and 3 and 4 because while it's telling me what's happening as we're approaching 2, it's not going to be specific enough because it's It's one whole unit apart. I want to see what's happening in tiny little increments. So I'm going to change this into what you saw was in there before, 0.001, because then I can see what's happening at 1.99009 and 1.999 and 1.998 and 1.997. Or I can see what's happening at 2.001 and 2.002 and 2.003. That's telling me what's happening as it converges onto 2 more accurately. So once you change these settings like this, again, make sure you go back and change those settings in the future if you're going to use a table again, because you don't want to be confused by that later. But now I can click second and go to table above the graph button. And now I can see that it started at 2, and I can see that from 2.003, it's negative 7.749, and then negative 0.749, and then negative 0.75. And on the other side, I can see it's negative 0.752, negative 0.751, negative 0.71. I can see what's happening as it converges in on 2. Now, if this was like I talked about in the notes, that this was like undefined at 2, it would say error on the 2 spot. But I can still see what's happening. On the top above 2 is negative 0.751, and below 2 is negative 0.75. So I can say that as we're approaching 2, it's approximately negative 0.75, which we said was the answer, right? The other thing that we might want to look at is a graph. And now, in terms of what I wrote for my example, I wrote down this table for 0.997 all the way up to 0.003. I just wrote that table, and then I said, okay, what happens at 2? I can see what happens at 2. It's at negative 0.75. If you wanted to look at it graphically, you could also click on this graph and see the graph. And I could look as x is approaching 2, what's happening, which is a little bit tough to see, right? I can't really make this out. I need to zoom my graph in. So I'm going to change my window values. What I'm looking at then is at 2, the graph is definitely negative. Y is negative. So I'm going to go in here to window. Now, I've seen some of you in class get confused by this. Make sure you reset your window back at the end. This is saying my x-axis. Where do I want my smallest x-axis and my biggest x-axis to be? So right now my x-axis is from negative 10 to positive 10. Look at the graph. It starts at negative 10 and goes all the way to positive 10. I want to change that because I'm focused on 2, right? So I might change this to 0 and 3 so that I can see the values around. I'm going to still leave it counting up by 1 because that's easy for me. I can count up by 1. I know that my answer is supposed to be negative, but it's not quite at negative 10. It's like, I mean, honestly, we know the answer is negative 0.75, right? So I'm going to put in negative 2. Just to bring my graph up. I accidentally typed on my, hold on. I can't type on my keyboard because that's a minus sign. Negative 2. There we go. My maximum, well, I know this graph doesn't go above the negative, so I can also put my maximum at 0, right? I could put it at 0 because I don't need to see that. And my scale, well, let's look at the graph right now. If I graph it, I can see based off this, I can see that at 2, again, we're just looking, you know, let me open my window up a little bit. Let me actually make my maximum Y 1, just so you can see that axis a little bit clearer. Now you can clearly see there's an x-axis right here. At 2, it's a little bit hard to see what's going on. I may have to change my window settings a little bit. In fact, I'm going to change my Y scale to 0.1. I know that's kind of a weird value. It's going to look a little bit messy, but let's do that. This is a little bit better. So at 2, I know that my scale is going up by 0.1. So I can see that, and I would probably have to take paper and hold it up and say that at 2, I'm at, I hold my paper up, I can see that's in between that 0.75. So that would help me get that answer a little bit more clearly. Obviously, graphing is not the most ideal way. It really isn't. You can just kind of see what's happening. So this is what my answers would look like. Like I said, I think the table is definitely more accurate. You could see very clearly what was happening as we approach 2. But on the graph, we could see that it's getting close to negative 0.75. So this is what I would put. So my final answer would be the limit as x approaches 2 of the function x minus 8 over x squared plus 4 is negative 0.75. Both those options are valid options. You can use either one. You could use both of them, whatever works best for you. I think a table is easier. A little bit more to write down than to draw, but there you go. So with that, we're going to go on to page 37. I would strongly recommend you watch page 37 before trying any homework. The homework all ties together. So I would definitely do that before you just jump on and try and do the homeworks. But if you have any questions, please let me know. Come see me in office hours so I don't have to spend them alone anymore. All right, bye everyone.